In this video, we're going to talk about the discriminant. So one thing that you need to know is that the quadratic formula do not only generate solution to a quadratic equation. It sometimes tells us about the nature of the solution when we consider the discriminant, which we are going to talk about in this video. Now, or the expression under the radical form of b squared minus 4ac. So the discriminant test let us know whether the solutions are real numbers or complex number and how many solutions of each type to expect, right? So with this table is gonna tell us the value of discriminant to the solution of a quadratic equation. So let's just consider this table that I have here. So with this table, let me scroll down to this the table here. So I have this table here. Okay, so the table we have, when we put the value of b, a, and c and get a solution which is 0, then we get a solution of one rational solution, right? When you put the value of b, a, and c into this radical form and get something greater than 0, then that will be a perfect square. Then the solution that we are going to get is two rational solutions, right? Now, when you put the value of b, a, and c, and you get a value greater than 0, which is not a perfect square, then the solution that we are going to get is two irrational solutions, right? When you put the value of b, a, and c, and you get a value which is less than 0, right? Then we get two complex numbers. So let's take some example and know how it works. So with our first example, we are going to use the discriminant to find the nature of solutions to a quadratic equation. So with the first one we have, and one thing that I want to let you know is that before we go to the main questions or the examples, for ax squared plus bx plus c equal to 0, where we know a, b, and c are real numbers, the discriminant is the expression under the radical in the quadratic formula. So the discriminant is the expression under the radical in the quadratic formula. So what is the quadratic formula that we're going to use to find the nature? So we are going to use b squared minus 4ac to do that. So this tells us whether the solutions are real numbers or complex numbers and how many solutions of each type to expect. So we will use this formula here to expect the nature and how many solutions we are supposed to get. So let's go into the main questions that we have here. So with our first example, we have a quadratic equation of s squared plus 4s plus 4 equal to 0. So with this, let's calculate the discriminant and see. So we know that calculating the discriminant, we are going to use the formula of b squared minus 4ac, right? So when we put the values of a, b, and c, so what is a here? A is 1, b is 4, and c is 4. So when we put b, a, and c inside, we should get, so we have 4 squared minus 4 multiplying 1 multiplying 4, right? So when we do it, we should get 16 minus 16, which is equal to 0, right? So with this one, when we go back into our table here, we got 0. So here we will have, there will be one rational double solution that we are going to get here. There will be one rational double solution that we are going to get here. So take note of that. Now let's go into question B. So here we have 8s squared plus 14x plus 3 equal to 0. So what is A? A is 8, B is 14, C is 3. When you put it inside, you should get 8 squared minus 4. What is A? 8. Then what is C? 3. So when we do that, we should get this 64 minus that, which when you do it, you should get everything here should be 100, right? So 100 is a perfect square. So when we go back here, we got 100, which is a perfect square. So 100, which is a perfect square, and is greater than 0. Therefore, the solution that we are going to get is two rational solutions. Two rational solutions that we are going to get. 100 is a perfect square, right? Now, let's go to C. So we see with the same formula, b squared minus 4ac, where b is 3, a is negative 5, so we have b to be negative 5 and a to be 3. So a is 3, negative 5, and c is negative 2. So when we put into 8, we should get, that will be, so this one was 14 squared rather, right? Now with this one, we should get, that's negative 5 squared minus 4 multiplying 3 multiplying negative 2. Then we should get, when you calculate that, we should get 49. Now 49 is a perfect square, so let's go into our table, back to our table. So we get something which is greater than 0 and also a perfect square. Therefore, what solutions are we going to get? We are going to get two rational solutions. Two rational solutions. So let's go to our last example here. With our last example, we have 3x squared minus 10x plus 15 equals to 0. So we're using the formula b squared minus 4ac equals to 0, where b is negative 10, a is 3, and c is 15. So we have negative 10 squared minus 4 multiplying 3 multiplying 15. And when we do that, we should get negative 80, right? So with negative 80, we have negative 80 to be less than 0, right? So what is the solution? What solutions are we going to get? So with this one, we have a value of less than 0. So there's going to be a two complex solutions to this kind of form. So this is the end of this discriminant video. And thank you for watching. I'll see you in my next video.